Warmly welcome to the next WWSC Alumni seminar. Today we have Karl Håkansson. He's a PhD student from the first batch of WWSC, already from 2009 you started. Yeah, it was a while ago, and you have done some super interesting things that we will hear more about. As usual, we have some people here in the room, and we also have people with us on the Zoom. And I think we will hear a presentation, and then when people have questions, they can either write in the chat, or afterwards, when we have the questions, you can also raise your hand in Zoom, or raise your hand here in the room, and you will answer, I hope.
Yes,
yeah. Right. So glad to have you here.
Thank you so much for inviting me. Great. Then I will talk about myself. And so how did I get here? Here's a timeline of my career, starting with my master's from Chalmers. And then I started 2009 here with KPH, doing my PhD in the WWSC. And then postdoc major prize, and also a okay. So the timeline, yes, let's dig into this. Engineering physics from Chalmers is my master's, and then I did my PhD here within the center, WWSC Science Center. Professor Daniel Söderberg, Professor Fredrik Lindell, and Professor Lisa Wittberg, they were my supervisors. Daniel is still in the center, and I think Fredrik too. Lisa more other stuff. And what did I do? We developed, so this was in fluid physics, and we studied non-spherical particles in flows. And the spherical particle, or non-spherical particle we worked with was nanofibrils. And I think we all know what that is. And we wanted to have a process where we align the fibrils, nanofibrils, into a filament. So what we did was we created this channel. And accelerated flow, the CNF is coming from here. We have two sheet flows. This is just water, and the second one is low pH. So these are surface charged nanofibrils, carboxymethylated. In this first flow here, you have acceleration, you align fibrils, because that's what elongated non-spherical particles do in an accelerated flow. And then, since these are surface charged, they will actually disalign again after the flow has stopped, the acceleration. So what we do, we have in this sheet flow, low pH, we diffuse protons into these, the fibrils, they get protonated, and you lock this into a gel structure. So you have your gel filament coming out. And we were able to and of course, during your PhD, you need to publish, so you publish papers. But it was also very fun to be able to be part of a patent application. And then came right along to the dissertation, which happened in 2014. This was my thesis. It is the final filament, but it would actually not into a old lady's knot, as that one is called. And what happened next was that also actually within the center, I was approached by Håkansson, professor from Chalmers. So I went to his lab and did postdoc, and was there for 2 years in the postdoc, and makes us a researcher. And you can see that this overlaps with my time at RISE also.
Then postdoc at Chalmers with Professor Paul Gottenholm, and there we did some 3D printing. So this is also with nanocellulose. We developed some 3D printing inks, one with just pure nanocellulose, and then you can make these small furniture for your Lego people that you have at home. Difficult to make any larger things, but more and more useful in the biomedical field, where you can have them wet and you introduce cells and these things. Okay, next. I got a position as a senior research associate at RISE, where I'm currently also working. And RISE is the Swedish Research Institute. Who here has heard about RISE? Okay, so yeah, in 2016, the major research institutes we have had for different industries in Sweden, they were consolidated into one that's called RISE then. And what does one do at RISE? Well, we have a lot of test beds. And this is one that I started working with, maybe one of the bigger ones. This is a paper machine that we have here on KTH campus, just a few hundred meters that way, where you can run paper trials, and it's full scale, but only produces A4 sheets. And on this one, then we work more closely with industry than academia does. Maybe we can have more applied research development for them. And so in this paper machine, we ran, or I started off running, a lot of nanocellulose trials, where we mixed in not the surface charged carboxymethylated, but more the MFC things for strength, for example. And at RISE, it's also working a lot with demonstrators, so showing the potential of the research to communicate this. And then here, this demonstrator is that we actually have inside the sleeve here, we have a conductive paper where we mixed in graphene or graphite, nanographite, not quite graphene. And if you connect this to a power source, you can actually run current through this and heating the coffee that you have with your USB port, for example. And then just a list of some differences maybe from what one is used to from academia as a PhD student. Usually at RISE we work in projects that are a little bit faster. The companies, they don't want to wait around for 5 years, unfortunately, but they want results in a month or two, or even faster than that. And then also the projects, it's always project work, which can be either very large, and I would say that maybe the WWSC is a very large research project. And at the Institute, we are involved in those, but also much smaller ones. So it could be just one company wanting to run an analysis that you do for a day or two or a week, which is also different from what you do here. And also a wide variety of different constellations. We can have many different companies, one company, or we can just do projects with academia. But you need to be good at project management, I think, or it's necessary to have some project managing skills. And I think you can get that also from your PhD while you're working here. Okay, but then actually now we go back to the filament. So during my time at RISE, I also continued to collaborate with KTH regarding the filaments. We wanted to produce more material. We wanted to understand the process better. And then the PhD student coming after me continued the work and showed that these filaments can have very good mechanical properties. Here we have a specific stiffness versus specific strength Ashby plot, where the nanocellulose filaments perform better than all the fibers you can find in nature. And this is then because we think we understand how to assemble these in a good way. And that gets us to CelluXtreme here, that was recently founded. So we tried, and succeeded some parts, selling research projects. I mean, we wanted to, we believe in the filaments from nanocellulose. We wanted to sell research projects saying, oh, please come work with us and pay us to do the research so we can develop this further. And at some point, we realized, maybe starting a company is the best way to take this the next step. So that's what we did. And that's how CelluXtreme was founded. And we are currently aiming for the lightweight market, since they are stiff and strong and lightweight. And this is very important in future automotive industry, renewable energy industry, also in sports, to have lightweight material that can last. And the solutions today are usually carbon fiber, glass fiber, and these blades here. So what you do after the 20-year usable period is that you dig a big hole, and then you stick these blades in it, and then you cover it with dirt again. And we don't think this is necessarily the best way to continue. And here we think that, and the reason is because it's so very difficult to, or it takes more energy to recycle them than it does putting them on the ground. So with our fiber, we think that we can make this a little bit more sustainable, and we think that this gives us a good value, and this both for us and for society, and also that we provide more new properties than the old ones. The carbon fiber, glass fiber. And I think this is a lot of the research that is ongoing here with all the functionalizations of the nanocellulose, for example, can be used in cases like this eventually. And I think this is, I mean, it is coming more and more. Yes. Okay. So the team, we still have a lot of professors here in the CelluXtreme team. Me and Matthias and Thomas are also WWSC students. Anna is the CEO. And then you might think, when you start a company, you need to do everything yourself. But there's actually good support you can get. And from here, then, since we are in Stockholm at KTH, we got some help from KTH Innovation, so setting up contracts and agreements and things like this, for example. And then now we are part of Sting, which is also an incubator in Stockholm that helps out startups with that, which is very nice to have that support, because it's, we are not experts in everything. Most of us are researchers and want to be in the lab and do experiments. And the status at the moment of CelluXtreme is that we're validating the technology. We're trying to produce more material. And as we have realized is that, I mean, when we make the filaments, you make one fiber, you can measure the strength of that. But then if someone says, oh, we think this is very interesting, can we please have some material to test in our product? They are not talking about 10 filaments, they are talking about 10,000 filaments or 100,000 filaments. So we needed to scale up the production a little bit to be able to get to that point. And I think we are soon there to actually finding the first use cases, and then we need to scale up even more in order to provide the market with enough filaments to fill that space. And we are also securing some IPR to be able to talk more about what we're doing. And then, so I was asked also to give some recommendations for the PhD students, and I would say that use the network. It is really big, and it is world leading in new materials from the forest. And I would say that even though it's scary to trying to collect and connect and collaborate with experts outside your own discipline, because that's usually how it gets really fun and interesting. It usually also takes a while for you to be able to communicate, but spend some time and discuss. It pays off. And then, of course, project management will most likely be part of your future career. But yeah, so with that, do we have any questions? Then thank you so much. Otherwise, I have to talk for more minutes.
Thank you very much, Karl. Do we have any questions? Eva? Maybe you can use this one.
So I made some notes.
Yeah.
I'm so old, I won't forget. I won't remember otherwise. Okay, shall I go forward? Okay. So first of all, do you think that WWSC provided you with the best possible preparation for undertaking your postdoc and your career in RISE and then as an entrepreneur, or did you miss anything?
I really enjoyed that you were not alone, as I realized some PhD students are when they are doing this. And I mean, yes, I mean, I would say I learned a lot. It's impossible to learn everything.
But it sounds pretty good. You didn't
Yeah.
miss anything that you can, pick right now.
No.
So it was nothing obvious that you missed from the package, so to speak.
No.
No. And then I think how do you combine your career as an entrepreneur and an employee of RISE?
Yes, it is a little bit tricky, but if you know the boundaries, it's very possible. And I think it is definitely possible to combine, and input from both directions benefits both jobs at the moment.
So you settle the agreement and then it's
Yeah.
perfectly fine.
Yeah, yeah.
And then I think you have sort of made an academic achievement in figuring out how these filaments could be made on the lab scale. And now you're sort of going to the upscaling, which will be the, I guess, critical step.
Yeah, yeah.
So how are you thinking about that? I mean, you said you're soon there, but I guess it's a matter
We're
of...
soon there in testing out what we can use
Yeah,
it for.
so what do you think is the capacity that you would need to reach to be like a really good alternative to being the reinforcement fiber in wind turbine or wind turbine setups?
Yes, I mean, so I see this as very, it's a lot of steps to get to the extreme scale, as the wind turbine is the extreme scale. But I think that there are products in between to get us there, because taking that big step, it's very, very difficult from milligram scale to 1,000-ton scale. So I see it as many small steps, and then you need to understand where you can add a value in every step in order to make an impact there, and then you take it to the next step. And then along the way, you decrease the production cost and will eventually be, can be very big.
So in an ordinary composite with glass fiber reinforcement, for instance, sizing of the fiber may be very important. Is that something that is crucial here as well, or?
We do not think it is crucial in our fiber. We see good properties without sizing.
And also mixing with the matrix component.
Yeah, yeah. But when it is a problem, we will come back here and ask you guys, of course.
You definitely should. That was a really good answer. So,
Yeah.
so thank you very much, Karl, for a nice presentation. Thank you.
Thank you, Eva. Do we have any questions in the Zoom? If you have any questions in Zoom, please raise your hand or write in the chat. Vasilis? Huh? All right. I don't see. So what positions do you think are in the industry for PhD graduates? Are internships more or less one way nowadays for one to enter the industrial environment?
So I'm not an expert in the industry yet, but if you see RISE as part of the industry, we do not have a lot of interns, but there are positions advertised, and then you apply, and then you get it or you don't get it. But I think it is I think there are a lot of openings at RISE. But then startup is a little bit different, and I'm just getting to know that world.
Yeah. I think that quite many of the PhD students from WWSC are or has been or will go to RISE at some point. So it seems like a quite common working place for WWSC PhD students.
Yes.
I guess it's somewhere in between the industry and the academia, so it's not so strange. Vasilis, if you're satisfied with that comment, otherwise you can raise your hand again. We have a question here from Alessio.
Thank you for sharing your experience. I would like to ask you if you have any recommendation or suggestion for who is approaching for the first time in entrepreneurship, especially for a young person that switch from research to startup that doesn't have a wallet, or private investments to do, and if there are mistakes that you would avoid to repeat, maybe at the beginning.
So I would say talk to KTH Innovation. They will, I think, help you with that. And then other than that is talking to either other people from the center that have started their own company. Reach out to them and just ask, say that you're a student or was a student and want to do this. I think that most of them will help answering these questions.
And at KTH, we have KTH Innovation, and I think at the other universities, there are similar organizations. Exactly. And I agree, they are very helpful. The little that I have been in contact with them, they are really helping out a lot. And I think also what you say, it seems like many of those who are entrepreneurs, they do it because it's so much fun. So they sort of enjoy talking about it as well. So maybe if you approach them in the sort of right context, I think you can get a lot of help from other people as well. Do we have any other questions? Yes, Paula?
Hi, thank you for the presentation. I will copy Alessio, but I will change like the context of the question. So I'm a first month PhD. So my question would be, you said some recommendations, but I would know if you had some advice of something during your PhD, like in your third year or fourth year, that you thought, oh, I wish I knew this in my first year, like maybe organization on your daily life, your approach on research, or yeah.
I mean, maybe it is about publishing papers. So
Okay.
take good notes and good experiments is always, I mean, important, because then you don't have to redo all the experiments that you did half-ass. You can do them well from the beginning.
Okay. So be organized.
Yes.
Okay. Thank you.
I agree. That's a good advice. Any other questions? Do we have anything from, no? So then I can ask you, because I was talking about having fun.
Yeah.
And I assume that most people who do go into entrepreneurial activities and startups, they do it because they are sort of very engaged and they have a lot of fun doing it, because it takes a lot of work, right? Because it's not like normal working hours, more or less. So then I would like to ask you and you do a lot of different things. That's also one other thing. So what things are you enjoying the most? What things, or what aspects of entrepreneurship and startups do you enjoy most?
Yes. So at the moment, it's actually being in the lab again. Since at RISE, I mean, you need to sell the product or the project, and then you can do it. And now we have sold enough or gotten enough money in CelluXtreme that I can be in the lab and do the things I was trying to sell before. So that is at the moment the most fun.
Yeah, that sounds good. Going back to the lab.
Yeah.
That's fine. So that's also an advice for all the PhD students. Enjoy the lab. You might miss it one day.
Yeah.
Yeah. Any final things for Karl? No? So let me thank you a lot for coming and help me with thanking Karl.
Thank you.
And thanks also to you guys joining via Zoom. We already have a new person coming for the next alumni seminar, and that is Christina Schütz, who is also one of the among the first ones in WWSC. Josephine, help me. It was the 25th of April, but I will send out the Outlook invitation also. And you will find it on Trees. And as always, you will find it on Research website and on WWSC website. They are linked in that thing. So, and you can also find there the old ones, information about the alumni persons who have been presenting, and also at least some of them have been recorded, so you can see them there. All right. Thanks a lot, Karl. Hope to see you soon again.
Yeah.